In this video tutorial, we will set up Apache Spark in ScalaIDE. So I opened the ScalaIDE that we have downloaded from our previous tutorial. I extracted it and started it. First, it asked me to specify the workspace. And I will put to Spark. Now cancel. We want to create a new workspace. Yes. Spark workspaces. You can define your own names, basically name of the folder where all project of Spark will be located. So this is the ScalaIDE. So next what we are going to do, we're going to create a Maven project. This file, new other, Maven. So we use a create a simple project with a group ID. It can be any group ID. I will specify like this. Example Spark, and the artifact ID also can be any Spark application. This is the structure of the Maven project that has source folders, Java, resources folder, and the tests, where you keep all the tests. So first we would update the POM XML. This file contains all important configuration for the project. So right now we're in default overview, but we need to open the XML overview. So now I will copy the POM XML already prepared before. You can find it also under this video is attached. Okay, now I save the file, and then the project will be updated. Now it will show the error. So we need to Maven update project. Okay. So after this we need, right now it's a Java project, but we want to have a Scala project, so we add a Scala nature to it. Now it will complain here because the Spark using Scala 2.10, but the ScalaIDE use by default 2.11. So to change this we need to go to update Scala compiler version, and for this we're going to right click on the project properties, then Scala compiler, use project settings, and here we put latest 2.10. Okay. Then we wait when it will finish to compile the project. Now it has a warning that we have more than one Scala library found in the project. So we need to remove the Scala library container from build path. So we go to build path, configure a build path, and then on the libraries tab, we're removing the Scala library container. We'll remove it. Okay. Now the warning is disappeared. Now we rename the source folders from Java to Scala. Right click, refactor, rename, Scala, and also the test folder, same Scala. Okay. Yes. Okay. Now we need to create a package with a name that we have specified as a group ID. So I just copy it, new package. Okay, finish. Okay, and now the project is ready to be used, and we will now create a simple Spark application that will be Scala based. So for this we will create Scala object, new Scala object, and we will put the name word count. Okay, let's create a class with name word count. I want to see the line numbers also. So the starting point of writing any Spark program is a Spark context. Spark context is initialized with an interface of a Spark configuration object, which contains various Spark cluster configuration settings. So first we will define the main function as the same as in Java. So we define function main with input parameters args and its array of strings. So now we will create a Spark context. Only one Spark context can exist within currently running. So we define first the Spark configuration object by using new Spark conf method, and then we specify the parameter, the application name. I usually put the same name as the class name, and we put the set master option with parameter local 8. So that means that we will run our Spark application on standalone local mode with using, that means that it will be running inside of our Java virtual machine, and with parallelism with 8 threads to be used to run the application. Right now it says that can't find type Spark configuration. We have to import it. So we put import org Apache Spark conf and save it. So this is just a configuration object, and now we create, based on it, we create Spark context. Spark context. So it also doesn't know what is Spark context, so we have to also import. So these lines of code create a context running in the local mode with 8 threads. So next we are going to create the resilient distributed datasets called RDD in short. So an RDD is a collection of records that is distributed across many nodes in a cluster, but in our case distributed across the 8 multi-threads process, 8 threads. So in this example we will create an RDD from the text file located on the local file system. files that are used in the projects have to be located under the folder resources. So here I create a new file. First I will create the folder called text files, and under this folder I will put all the time I will put just only text files. Okay, so right now it's empty. I will go to Wikipedia and we'll just copy paste the text from there. Yes, and save it. So it contains some text about Linnaeus University. So now we will create an RDD from this text file. Just one more thing, val means it's a static variable in Scala, and var is not static variable in Scala, so value can be changed within the program. Okay, so now we do text RDD. So we use a Spark context, and then we use the text file, and here we put the path to the file. In our case it's main resources, text files, text. Okay, so it will return the object text RDD, that is a collection of records where each record is a string object that represents one line of the text file. And next, what we are going to do also, we want, for example, to count the words in this text file. So for this, we will use several transformations and actions. So first we will use flat map transformation. Not with these brackets, where we iterate in each line, and we apply this function. We split each line into the words by using a white space. This is in Scala syntax, this is an anonymous function, and this operator defines this anonymous function. So on the left side of the operator is the input to the function, and on the right side is the output of the function. So by using flat map, we split each line into words. Next, afterwards, we assign for each word a value 1 by using the map function. This is a very most used function in Scala. So there is also anonymous function. So for each word we assign value 1, and then we use reduce by key transformation, where it would count the words with the same key, that has the same key. So here, this is the functions applied on the values of the key value RDD. Since here we have created the key RDD key value where key is word and value is int 1. So, and by applying reduce by key, we make an aggregation on the keys. So all values will be summed in. So by this we will know how many each word was occurred in the text file. And save it. And now to show the results. This is since the counts right now is a collections of as you see here, it's already showing the string and int. It's a key value pair. The string is a word and int is the count of the number of the words. So I'm applying the action for each. And for each of the record, I print it in a separate line. Print ln. Yes. And in the end, we have to stop after the all execution has been done. We have to stop the Spark context so that we can run it again next time. Yes, now we can run the Spark application. We just need to right click on a file, word count Scala, and run as a Scala application. Okay. Then in the console, okay, right now we have an error. It says that the input path doesn't exist. So we need to check if you specified collect source asserts main resources. Okay, it was a mistake here. Text files text. I'm save it and run it again. Here is the output. So that contains a word and the occurrence, the count of the word in the text file. And it also contains a lot of information here about how the Spark context is running and so on. So sometimes there are a lot of information like this and not convenient to see the output. So it is also possible to introduce a log for JS properties, profile properties. Yes, to filter the logs. So for this we can create here the file. You can also download, I have it already here, log for J properties. Just copy it. And here you will create a new file. Yes. And save it. Yes, and now we can try to run it again, and let's see. In this we can change info to error, showing only errors. We save it. We try to run it again. Let's see if it makes some influence or not. Yeah, so now we see only the output of without additional information. But sometimes it's useful to have info in case if something wrong happening and there is no error, but the behavior of the application doesn't behave like it is. So sometimes it's better to put also info back here. But for these simple applications, you can filter the logs to the level of errors instead of info. Okay, good. So this is it is for this simple and running example. Yep, that's all.